Hello, today we're going to create a remote controller system that could enable almost any electrical device remotely from your phone. In a nutshell, we will have three components. First one is Android WebSocket server application. It will send commands through the Wi-Fi network. The second component is ESP device. It will be connected to the same Wi-Fi network and it will receive commands from the WebSocket server application. And the third component is error light device. It will be connected to ESP and it can enable and disable any electric circle. I'll guide you through the full process of creation from the very beginning to the results. You can find all useful links in the description under this video. Let's start. We can go to our repository and copy the link from HTTP tab. Then open terminal and clone the repository to our folder. And after we will review the code. When cloning is done, we can open the root folder of our repository. As we can see, it has Android and ESP32 projects inside. Android is a project based on Gradle and ESP32 is a C project. Okay, it's time for Android project. Let's open Android Studio and Android folder. It will take some time to download all dependencies, but eventually it will open the project. And now we can review components by component. The first and the easiest one is main application. It's an empty class, it was required by Hilt's dependency injection library, so we just created it. Next component, it's main activity. It's our entry point and it will be opened with our application. It has main view model, its MVVM pattern, it has onCreate method with subscription on some events from view model. As we can see, here is several flows with subscriptions, and it has main screen that just show UI to us. We are passing parameters to main screen, devices, IP address, port, and last but not least we are passing actions, which device which will be triggered when user switch state of relay. The next file is the main screen. It has set of views and some styling. For example, text style. Also it has like header of the file where we see IP address to connect, and we will have real devices in the list, and each of device will have own switcher to switch state from enable to disable, and this state will trigger a unit that we passed from the main activity that triggers our view model. Our view model is very similar to something like middleware guy. It has links to WebSocket server, to network monitor, and it grabs data from there. As you can see here, we have connected devices and we just pass it from WebSocket server to UI variable. We expose it up. And also we expose IP address from network monitor. Last but not least, it calls WebSocket server and asks it to switch device state from on to off. Now we're moving to the most important part of our application. It's a WebSocket server. This class has a reference to the server by itself, and it has also states of connected devices. We can see mutable state floor here with list of connected devices, and we see exposed connected devices list for listeners. We also have scope with dispatchers IO, and we have a map to hold link to WebSocket attached to device ID. We can reference to it in the future to send a message to a concrete device. And we have list of states. Also, we have a mutex to synchronize our code, so it will help us a bit later. I don't want to be Captain Obvious, but the start method will start our server. Line 54, start listening to a port. Also, Ctor requires to install WebSocket plugin, and we just need line 56. In the same way as HTTP protocol, WebSockets also could have multiply different URLs, but we don't need them, we need to handle only one case. Next part of code will be executed when actual device connects to our server, and it will send OK message immediately. Also, it will update the UI with method, and it has infinite loop. It reads messages until the device is disconnected. And when device is disconnected, when connection is closed, we will update UI again. We remove our WebSocket from map by ID. A method that updates UI is pretty straightforward. It has list and it builds it from connected device from a map and notify our flow. And basically it sorts it by ID. And we have a stop method which kills the server and sets null to references. Another important part is a switch device state method. It gets opened WebSocket connection from a hash map by ID and send command. In the end of the file we have constants with a port and data class that describes connected device with fields ID and is enabled. Now we can move on to the network monitor class. It was designed to listen to Wi-Fi networks, and as we can see we set transport Wi-Fi here. Also we register this callback to connectivity manager, so we listen networks, and when network become available we loop into the available addresses and look for IPv4 IP address, and we set value to our flow. And that's it. Now we can test our application. Let's run it and see what we have there. To test the Android part, we'll need to install WebSocket application and make sure that you have it, or go to my GitHub and see dependencies there. Another important part that you should use real device connected to the same Wi-Fi network, because it will have a normal IP address there. So let's type WebSocket and our WebSocket address. As we can see, it's sorry, my mistake. We are typing it, and now we are typing port and press enter. We received OK. It means that we are connected to the server, and we can switch, and we see that the state is updated and application sends states of switcher to console. Okay, that was it for Android. Now let's move on to ESP project and Visual Code. Just press open and select ESP32 folder. Yeah, it will ask us some questions, but of course we trust. It will take some time to download some dependencies, and let's open. Oh, it even detected that it's an ESP project, but if it didn't, go to view, and then you can open command palette and type ESP IDF configure. By the way, if you don't see any ESP IDF plugins there, you should install them, so please go back to GitHub and check description and required software. Now let's use Express installation. We can check the latest available version. We should set some folders here. Let me select it. And we can copy it here and type ESP tools. Yeah, let's press install and wait until everything will be downloaded. And while we're waiting, we can review some files there. Let's open CMake lists. It proposes to install plugin for CMake. So let's press install there if it proposes and press install. Plugin is installed, so we can adjust some sizes of toolbar, and I guess we should adjust size of fonts to be able to see more. Give me 1 minute. Yeah, that's much better. Okay, so it's the main line here. We need to know that the project should be called app main, and we have main folder and app main file there. We can open it and it should have app main void method. We are going to connect our device to Wi-Fi network, so we need to have Wi-Fi config. We have config example, so copy it and rename to config.h. Let's remove it. And now we need to put actual data here, like IP address and Wi-Fi seat and Wi-Fi password. Now let's go back to app main and start our operational system. And it has some mechanism to erase if something went wrong. And the next step is to set direction of our pin. We will use output only because it's relay device and we should control it. We set GPO number 4. We will connect the relay device to this number, to this pin. Next we are going to start Wi-Fi connection. Let's move to that file and let's see NT Wi-Fi connect method. This class will call init method, and also it will create a loop for events. Also it creates default config for the Wi-Fi and it subscribes on some events from the system. Next important part is modifying a config. We use Wi-Fi seat and Wi-Fi password here, so we will connect to actual access point. We set some mods and we start the Wi-Fi. When Wi-Fi will be connected, we will receive events in event handler. So all information will be available here. We have Wi-Fi event, Wi-Fi start, disconnected, and here we have event got IP. It means that we actually received IP address in our network and we are ready to use it. Let's go back to app main file and proceed with WebSocket connection. We have WebSocket connect method. It also requires some configuration. We have VS host, VS port. We can find them also in the config file. We set IP and port, and then we are calling WebSocket client init method. After it, we register events and we are listening to WebSocket events. So next we are starting the client, and now we can go to our handle method. It will receive all events from WebSockets. We have some arguments here like base, like event ID and event data. We will print everything we received here and handle main cases like disconnects. And in this case we will set GPO level 0. It means that we will disable our relay device. Our target event is WebSocket event data. We will receive all messages there, and we will handle it, and we have some constants like message on and message off. We send them from the Android device, and in this way we will understand when to enable and when to disable our relay device. In any other event type we will disable our GPO because we don't know what else to do with it. And this code will cover everything we need. Let's press the build button and see if we have errors there. Let's speed up process a bit and see the results. Okay, if we see this type of message, it means that the build was successful and we can install it. So let's move to the next exciting part and assemble everything together. Okay, let's grab our ESP board and unpack. Next we will unpack relay module and let's look on it. On the left side we have DC plus, DC minus and input. It will power the relay device and control it by input. On the right side we have three interfaces. Common interface means that we should connect our power line there. Normal closed means that if you connect something to common channel, it will immediately be passed to normal closed, and normal open means that it will be connected to common channel only when you activate the relay. Now let's use a screwdriver and connect wires to relay module and to ESP module. Unscrew first. And we are using yellow wire for input channel. We will use red and blue wires for neutral and for line. So let's connect blue to minus and red to plus. And screw it tight. And that's it, we are ready to connect our ESP module to this relay. It has a lot of pins, but our target is D4 on the bottom part of the board and VN and ground on the upper left side. The blue wire connects to a ground pin, red to VN, and yellow we should connect to D4 pin on the other side of the board. And that's it. Everything is assembled and we are ready to install our software on this ESP board. Okay, now let's look on our system in action. We have ESP board, we have relay module, and also I recommend to use adapter. It will help us to avoid critical damage to our laptop if we short some pins on our ESP board. We connected ESP to adapter and we connect adapter to laptop. Let's press a fire button, it will start a build, then install it and then monitor the device. By the way, we can see red and green lights on our boards. It means that power is on and they are ready to be operated. Now we see Wi-Fi got IP message. It means that we are successfully connected to a Wi-Fi. Let's wait until WebSocket will be also connected. And here we go, we see connected, we see that we received OK, and let's look on our UI on the phone. There should be, oh yeah, and here is a connected relay device. As you can see, like now I'm going to switch it. If you hear clicks, it means the device has switched its state. Also, we can see a red light on it. If you see it, it means the device received a message on, and now common channel is connected to normal open channel. Good. To see it in action, I'll grab some extension cord and some lights and connect it to the relay. I have to warn you that power sockets and high voltage extremely dangerous. It could kill you, and that's why it's better to choose something more safe, like LED strip lights powered by batteries. Now I'll turn it off and cut the wire. I need to clear it from isolator. Now I will enable control block and connect two wires. It's time to put wires into the relay. I will connect wires to common channel and normal open channel, NO. It means that the lights will remain disabled until relay will enable it. Finally, we can turn on the power for ESP. It will take some time for the board to connect to the Wi-Fi network and then receive IP address and then connect to your phone. The first launch will take approximately 1 minute, but yeah, we see it. Now let's turn off lights in the room. Looks much better. That's it. Now you can control a lot of devices remotely from your Android phone. Thanks for watching. Feel free to reach me out in comments. I'll try to help you if you have any questions.